service.
Is it moving or still?
Now it is static. Can you try moving it, sir?
Yeah, we are moving, but
no,
you see
static over here. I think if you change it into the full screen mode, it will be moving.
Okay,
yeah, now it's moving.
Yeah.
Now it's moving.
Now it's moving. Okay.
Good morning, sir. Rajesh, sir, good morning.
Good morning. Good morning.
Good, sir. Yesterday was a very good and informative lecture. I hope today also will be like that. Anyway, thank you for taking the initiative, sir.
Thank you. Well, it is on the part of RST director, sir. So shall we start now, sir?
Yeah, definitely we can start, but we can request all the participants to put their mic on this mute mode.
I think I request all the participants to put their mic as well as video in mute mode, so that there is no disturbance.
The mic there is a little problem. Sometimes noise.
Yeah, that's true. Kindly mute all your mics. It is very important because once the session begins, then it will be very difficult if there is some disturbance.
It is going on social media also.
Yeah, it is going on. It is being transmitted live on YouTube and Facebook also. So kindly ensure that the mics are muted so that there is no disturbance when we start the session.
Okay. Thank you, Rajesh.
Yes. So we can start, I suppose.
Yes, definitely. A very good morning to everybody. We welcome all of you to this national webinar on constructed wetlands in nature-based solution for domestic water treatment. First of all, I would like to welcome our esteemed resource person, Dr. Sabu Joseph, who is a very eminent and renowned person. And in the field of scientific community, he already has a lot of respect he commands in the field of environmental science. And he is presently working as a professor and head Department of Environmental Sciences and Dean of Faculty of Applied Sciences and Technology, University of Kerala. We are very thankful, sir, and very obliged also to you for agreeing to our request and also for sparing your valuable time for this meeting.
Thank you very much, sir.
Thank you. I am very happy to inform you, sir, that in this meeting we have with us our senior colleagues from different regional centers and learner support centers of IGNOU. And they are very keen to listen to you. The students have also been informed, but now we have advised them to watch this lecture only through YouTube or social media. Dear colleagues, the topic which we have for today's webinar is very highly and relevant in today's context. And as you know that across the world, also the domestic water treatment is of great concern. It is estimated that over 80% of the wastewater goes into the water bodies without proper treatment. And it poses a major health hazard and also threat for the sustenance of ecosystems, animals, humans also. Untreated water also adversely affects the yield of the crops and also gives rise to several waterborne and water-related diseases. And after 75 years of independence, when we see ourselves, we find that we are still facing problems related to unclean drinking water, and it poses a serious threat to public health and the environment. So in this kind of a scenario where we face the water scarcity, this wastewater recycling has to be properly managed. And in this context, the discussions which we are going to have in today's webinar are going to be very meaningful, especially keeping in view of our activities in villages under Unnat Bharat Abhiyan. I must tell you, sir, that under Unnat Bharat Abhiyan, our university is making interventions in the adopted villages in a very big way. We have 57 participating institutions across the country, and every regional center is a participating institution of this Unnat Bharat Abhiyan. They are students and the faculty from the regional centers. They go to the communities and try to sensitize them on various issues of concern related to that village. So in this context also, I request you to please educate us about what can be done about this domestic water treatment. So with these words, sir, I again express my sincere thanks to you for being our resource person today and also for agreeing to deliver this lecture. Now I request our Senior Regional Director of IGNOU Regional Center Trivandrum to please start further proceedings, please.
Thank you, sir. As you rightly said, this is a very important topic that we have for discussion today, because the world over, and especially in India, we have a very difficult task of reducing water pollution, increasing water supply, and protecting the environment, all three in one go. And today's discussion is based on wetlands, and their treatment systems are very important, because these mechanisms, I understand, use the natural processes of wetland vegetation, soil accretion, and associated microbial practices to enhance the quality of water. And I'm sure our eminent resource person today will have a lot of inputs to give us. And as you rightly said, sir, under Unnat Bharat Abhiyan, we may be able to take up many of these activities across the country to bring out very fruitful results once we go along. For the benefit of our listeners, I would now request our Assistant Regional Director, Sri Dr. T.R. Satyakirti, to give a brief profile of our very eminent resource person, so that our viewers also know the areas in which he is working and the kind of expertise he has. Over to you, Dr. Satyakirti.
Thank you, sir. A very good morning, all of you. Today, we have an eminent environmentalist and a great educationalist. So I take the privilege to introduce him. Professor Dr. Sabu Joseph is the head of the Department of Environmental Science, University of Kerala, and is also the Dean of the Faculty of Applied Science and Technology, University of Kerala. His major research interests are in the area of hydro, geochemistry, then geographical information systems, remote sensing, then environmental geology, etc. He has done his PhD from the University of Kerala and his postdoctoral from the University of Kerala under the CSR as a CSR fellow. And he has held several honors and awards to his credit. And recently he has been awarded with the Paristhiti Mitram Award of 2024 by the government of Kerala. He is an environmental expert of the National River Conservation Directorate, Ministry of Water Resources. And he's a great scientist with many publications, and he has an H index of 20 to 26 and I index of 38, etc. He has published more than 100 articles in several international peer-reviewed journals, and he has written several books and many book chapters to his credit. He's a NAC peer team member and has headed several committees under the Government of India as well as under the Government of Kerala. He has awarded 13 PhD students, and he's a member of. He's a mentor for many of the PDF students also. He's a fellow of the Geological Survey of India and a member of the International Water Association. And he's also a chief editor of the Journal of Integrated Earth Sciences and editorial member as well as peer reviewer of many of the reputed journals across the world. And he has several international and national projects. And one of the very important projects that he has successfully completed was an Indo-Israel project worth of around 6.4 million. And he's also involved in several of the in the institutional activities as well as social activities, which are very much relevant to the environment. So on behalf of the Regional Services Division as well as the IGNOR Regional Center Trivandrum, I cordially welcome him for his talk. Sir, over to Dr. Rajesh for the.
Thank you, Dr. Satyakirti. Now it is my proud privilege to welcome Professor Sabu Joseph, Professor and Head, as well as Dean of the School of Environmental Sciences, University of Kerala, to deliver his lecture. Over to you, sir.
Thank you, sir, for the kind words about me. I will just upload my PPT straight away going to the presentation. Thank you. Screen window screen Sir, can you hear me?
Yes, sir. You are audible, sir.
Your audience.
Can you see the slide also?
Yes, yes.
Yes.
Okay. Can you see the second slide?
Yeah.
Yeah, it's okay.
Okay, sir. Okay. At the outset, I take this opportunity to thank Indira Gandhi Open University for giving me an opportunity to present my small talk with you. I'm very grateful to Rajesh sir and Rajendra Billa sir for the kind words about me. I'm basically a geologist ventured into environmental science. So our topic of presentation is constructive wetlands, a nature-based solution for domestic wastewater treatment, as already mentioned by the previous speakers. So before going to this actual constructive wetland, I will give you an overview of the water pollution and some of the aspects related with this one. So this is slide number 2. I think you can view this slide. What you see is actually the Sustainable Development Goals given by UN in the year 2050. So this actually shows 17 goals set by the UN in various domains of the earth. And out of this various domains, I would like to project item number 6, which actually indicating clean water and sanitation. I think you can see this yellow bordered item, that is clean water and sanitation. So this was actually, these all 17 goals were put forward by UN in 2015 with a target of 2030. That means by 2030, all the targets can be achieved. I would like to bring your kind attention, item number 6, which actually shows clean water and sanitation. There is a guarantee by UN that by 2030, all people on the earth would have clean water and sanitation. Now I will take you to this one, to the present status. So this is actually now 2015. Now this is 2024. About 9 years actually completing by 2030. Only 6 years are remaining. So and under this category, you can see the present status. In 2021, UN has identified the status of the water pollution, and so 1 in 4 people throughout the globe lack safe drinking water. That means 1 by 4 of the people, 2 billion people in the world has lack of safe drinking water. Okay, almost half of the global population lacks safe sanitation. That means 3.6 billion people. 44% of the domestic wastewater is not properly, safely treated. These three aspects actually dealing with the quality of water. The second, fourth one actually dealing with the quantity of water. Global water demand is projected to increase by 55% by 2050. So water, when we think about water, two important aspects are there. One is the quality of water, another one is the quantity of water. These two aspects are very much important as far as country like India. That is why we have taken this particular topic. Now, if you look into the UN World Water Development Report 2023, it says that Sustainable Development Goal 6 actually achievement is very, very slow now. If things go like this, it cannot be achieved by 2030. Practically speaking, we all know that it is impossible. So UN says we need 4 times faster. What are the activities going on various parts of the globe, various countries? It should be 4 times faster. And also UN requests all the countries to building partnership and enhance cooperation within the country and between countries, so that this type of clean water and sanitation by 2023 2030 can be achieved. So with this background, actually, I'm going to the various aspects of even though our topic is nature-based solutions, I'll give a brief aspects of types of water pollution, challenges in water pollution status in India, and management options. I think water is, we know very well, it's a very important issue. If you ask anybody about water, they say one type of problem with water. If you ask a school children what is the problem with water, he or she will give one answer. If you ask a ordinary man, he will give another answer. If you ask a politician, he will give another answer. If you ask a scientist about what is the issue with water, he will answer. He will give another answer. So if you combine all these answers, it will finally come to 2 aspects. One is related with the quality of water, another one is the quantity of water. It's a very important issue. And we know that life is originated in water, and life sustained or maintained by water. And this is the only planet in the universe where water occur in all the 3 forms, like solid, liquid, and gaseous. So very important critical resource. It is not a commodity. Sometimes you can come across people filling bottles and selling water. They think that they're taken for granted. It's a free gift of nature. Whatever they want, they can do it. So that is not a thing. It's not a commodity. It's an important natural resource. We have to conserve it and preserve for the present generation as well as for the future generation. If you look at the price of water, it varies from place to place depending upon the demand. In India, for example, in Kerala, 1 liter water may be 20 rupees. But it varies from, if you go to other countries like Europe, the price of 1 liter water is very costly, 2.5 euro, something like that. And if you look in the price of water in the moon, there is no water in the moon. It has to transfer from the earth. The astronauts, when they take 3 days to go to moon and 3 days to come back, 6 days. If you take into account all these things, the price of water in moon is approximately 1 million, 10 lakhs rupees. That is, so it's a very important resource. We have to conserve it and preserve it for the present as well as future generation. And we know how the water is so occurring in the earth. 3 ways are there actually. Mainly 97% of water is in the ocean, and remaining 3% of water on the land. That means fresh water is a very small quantity on the land. If you look into the fresh water, you can see that major portion is in the form of lakes, water bodies, and a small portion in the soil, moisture, and other things. I'm bringing your kind attention this table, actually showing the distribution of water on the earth. So all the yellow colored aspects, ocean water, water that is in the landlocked region like glaciers size, groundwater below the water, this 0.6%, lakes 0.00%. The last one I will bring your kind attention, the rivers. Rivers are only 0.001% of the total water on the earth. Normally, we think that the river water is abundant, huge amount. So without knowing the limited quantity of this particular resource, people started polluting, particularly developing country like India. most of the developed countries, they almost treat the water and they dump into the water bodies. But in most of the countries like India, we are not properly treating, and the untreated wastewater is coming to the water and getting polluted. When we talk about the water aspects, particularly rivers, particularly policy makers, we normally say that river water is very, very limited in quantity. So you have to be very careful when we deal with any river valley projects like check dams, dam construction, drinking purpose, all these things. So it's a very small quantity. It's a very critical resource. That is the message I want to bring based on this slide. And these are some of the snapshots of the ice-covered regions like the polar region, Antarctica. You can see. If you look into the usage of water, 90% of water is used for agricultural activity. But globally, only 69% is used for agricultural activity. Some of the developed countries like US, most important use for industrial application, followed by agricultural activities. So India, we use huge amount of surface water as well as the groundwater for agricultural activity. India, China region, which we call it as the Southeast Asia, it is considered as a locomotive world economy. If you click on the Google and if you look into the water-stressed regions of the world global map, you can see that the most water-stressed region in the world is actually Asiatic region, particularly India, China region. It will be showing red color. What is the reason? Because major portion of the water that we are actually pumping out too much amount of water from the interior for agricultural activity. So this region is actually most important region from a agriculture point of view. So knowingly or unknowingly, we are using huge amount of water for the agriculture application. As a result, water table has gone down. So this region, we call it as the water stressed region in the world. So that is the most important reason. But most of the policy makers and the politicians not clear about whether our country is a water stressed region. If you take India closely examine, you can see that the north western part of India and southeast part of India, northwest Punjab and Tamil Nadu in the southeast. These are the real hotspot of the water stressed region. Too much water we are pumping out. So I am just skipping some of those slides. When we come to the water pollution, I have shown you a slide showing the brown colored water. So water pollution means we have three components as far as water is concerned: physical parameters, chemical parameters, biological parameters. If there is any change in any one of the physical, chemical, biological change, we call it as water is polluted one, and it has to be treated for various application for drinking and other purpose. Okay, these are some of the basic things I think most of the participants know. I will just skip some of the slides like water pollution, physical pollution is there, chemical pollution is there, biological pollution is there. Whenever we say about the physical pollution of river water or even groundwater, it is mostly change in color, water, taste, all these things are there. We normally test the water for pH or conductivity and say whether the water is good for drinking or not. When we come to the chemical pollution, we can say that it is the content of dissolved oxygen in water, DO content. Usually when the DO content is very low, water is not good for drinking and other activities. Similarly, we take the another important parameter, that is the biological oxygen demand. If the organic matter in water is very high, we say that it's a high biological oxygen demand. Similarly, if there is a chemical pollutants from the factories or industries, we say that high chemical oxygen demand. So these parameters, particularly low dissolved oxygen, high BOD, COD, this term that when we used to mention the chemical pollution water. Then we have the biological pollution, the third aspect. That means coliform count in water. We know that total coliform and fecal coliform. And fecal coliform is a very important thing for drinking purpose. If there is one fecal coliform count in the water, as per the Bureau of Indian Standard, it is not good for drinking purpose. So when we take into consideration the different water bodies, we have the surface water pollution, groundwater pollution, marine water pollution, out of which I would say groundwater pollution is more critical, because when we add some pollutant in below the soil, we cannot retrieve that pollutant. It will go into the water, it will pollute the water. We cannot see that water also. So retrieval and bringing water to the water to normal condition is really very, very tough aspect. But on the other hand, the surface water pollution and marine water pollution, at least these water bodies we can see, or because they are on the land surface, treatment is possible to considerable extent. That's why I am concentrating on this constructed wetland or the nature-based solutions. Before going to that one, you should know what are the major challenges in water pollution. As rightly pointed out by the welcome speaker, domestic waste, actually, we call it as sewage water or sunlight water, then solid waste. So these are actually knowingly or unknowingly dumping into the river system, our lake system, and polluting the water bodies, making them unusable for agriculture purpose, drinking purpose, all these things. In addition to that one, we have the factories and the industries releasing effluents. We know that there are treatment plants there in almost all factories, industries, but at least some areas, they only partially treat the water and it is releasing into the nearby water bodies, creating problems. And we have some of the emerging challenges in water pollution. I think this is a very important part. Emerging challenges, new challenges that come across in water pollution. We might have heard about plastic pollution. I bring your kind attention, microplastics and nanoplastic pollution. These are the things actually getting into the water body throughout the globe. A lot of
The voice is not coming.
Sir, you are not audible, sir. Sabu, sir.
So your voice is. Sabu sir, your voice is not coming up.
or unknowingly, it gets into our human body and it is creating problem. Even the human blood also containing microplastic, the placenta of the mother also containing microplastic. Anyway, the mother feeding that milk also containing microplastic. That's a very important thing. You have to take it seriously, consider it, and a lot of research going on to how to tackle this microplastics. Second one is the secondary microplastics actually generated by the microplastic that we throw into your environment, passing through the water bodies, ultimately reach the coastal area. The strong waves are there, so they pulverize. They actually break the microplastic into smaller particles. It is commonly seen in the coastal environment, and these are the photographs of the scanning photographs of the microplastics. Various size shapes are there. I'm not going to the details. I will just bring your kind attention this emerging pollutant in water body and how it is getting into the human, body. You can see this is the ocean water. In the ocean water, the microplastics are there. The underlying water, microorganisms or various organisms eat this one. Even the fish also eat this microplastics. From small fish, it is going to big fish and it is taken up.
Again, sound is not coming.
Sir, your audio is not coming, sir. Sabu, sir.
So audio is breaking. It's not. Sabu sir, audio is not.
Once it is going to the soil or water, the microbes there, microbial bacteria is there. It actually eat this one, and bacteria usually develop immunity through mutation process. And once this bacteria get into our human body in the form of drinking water, all these things, whenever we take further antibiotics, it will not work on human body. It is considered as a silent pandemic, much worse than the COVID pandemic that we came across throughout the world from 2021, 2022 peak periods. So antimicrobial bacteria, AMR is another important area. These are two important things. So the effluents coming from the hospitals, all these things coming to the land, soil, all these things, from there it is ultimately coming to the human body. So this is actually showing the life cycle of this, how this is moving from one domain into the another one. So these are very important things, the emerging micropollutants. And as I mentioned earlier, we have the sewage, the general, the common wastewater that is coming from domestic level. We call it as sewage. It has two components. One we call it as grey water or sullage, and the other one black water. Grey water means water coming from a domestic area without any fecal or microbial contamination. But the water coming from a domestic area, particularly from toilet or urinals, it contains fecal contamination, that we call it as black water. So nature-based solutions are possible to treat this sewage as well as the grey water and the black water. And these are some of the other major challenges in water body. I will show you some of the slides due to this water pollution. Fish kills incidents are there in the water bodies. We come across this issue in Kerala. Many of the rivers in Kerala are polluted, particularly one river, we call it as Periyar River. On the banks, there are so many factories, industries. Knowingly or unknowingly, they once in a blue moon, they release the partially treated wastewater, causing this type of things. And this is another kind of snapshot from Kerala, central Kerala. We call it a Kottayam. So you can see a highly polluted river system due to the nutrient-rich water. The factories and other things from the nearby area or the domestic level, you can see the flat system over in the northern part. So partially treating wastewater is coming to the region and causing this type of aquatic blooms, which we call it as the algal bloom or aquatic weeds. And this is another snapshot of a river system, a small river, we call it as Killiar in Kerala, Trivandrum. This is the upstream part of the river. And this is a 25 kilometers length the river. This is the upstream part. You see in the upstream part itself, the water is polluted. One of my students is collecting water sample here. Lot of foul smell is there. Without closing the nose, it is not possible to collect water here. So that is a condition. I would say that this river, Killiar, is not a river. It's a pollutant transportation canal. During monsoon season only you get river water. So this is actually the downstream portion of the river, the same river near to the coastal region. What you see is it's black water. It's not tar. It is black water due to the domestic pollution from the nearby area. I took this photograph nearly 5-7 years back. Okay, this is another portion of the same river where the Killiar is joining with another river. We call it as Karamana River. This is also the downstream portion of the near to the Trivandrum area. You can see the black lead water over here, and this is clearly showing the junction, the downstream portion of this Karamana River. See, 2 layers of water. Wherever you go in India, most of the places you can come across this type of water pollution, and the canal is draining this one. So what's the problem here? Without treating water, without treating the sewage, it is directly receiving into the water body, creating a problem. So that type of things. This here you can see the riverbed containing so many different types of plastics. I already mentioned about nanoplastics and microplastics. This is the way plastics are formed in the riverbed system. So this is another photograph of biological water pollution, animal bathing in the river system. Now, Government of India actually banned all these things. You cannot do such activities in a river system. Okay, we have different source of water pollution. Natural source there, as well as man-made source. So I already mentioned about the man-made source of this water pollution. We call it as a point source as well as non-point sources. Either wastewater coming from buildings, flats, residential complexes. All this call it as point sources. On the other hand, from the agricultural area, once it is coming, we call it as non-point sources. So this blue colored portion is a schematic of a river system. From various sources it is coming here, ultimately polluting the system. So we have agricultural area, pesticides are there, fertilizers are there. Nowadays, farmers actually using huge quantity without actually measuring the actual need. That type of things creating problem. Then we have the mining areas. Mining areas actually, either whatever we left over there, the unwanted things that is during monsoon season, draining into the river system and ultimately polluting. Similarly, we have the acid mine drainage, which actually call it as the sulfate content from the mining site actually coming to the water bodies, lowering the pH of the water. Water become acidic. So all these things are there. Then we have the thermal pollution coming from the thermal power plants, nuclear power plants, all these things, even from cooling in the industries. Hot water is coming into the nearby water body. That is also facing another issue. So this example of a thermal power plant in Iceland, I have seen this place. I visited so many countries as a part of my research program. This is one thing, the thermal power plant actually polluting the nearby water body. You can see the blue colored water over here. And then river pollution, I am just skipping all the slides, this type of things. And then we have the lake water pollution. As I mentioned earlier, similar to the river water pollution, we have the lake water pollution. From various sources, it is coming into the lake system, ultimately polluting that one. When a lake is polluted, we call it as eutrophication condition. That means you can see this algal blooms in a lake system. This is not a clean lake, green colored lake, due to the nutrient rich condition there. The nitrate, phosphates, all these things coming from the nearby agriculture area polluting. On the other hand, you can see towards your right side a clean lake system. So compare these two, get an idea how the lake is polluted. This is another polluted lake that we come across in nature. So various sources of pollution, so all these things are there. If you look into the pollution, water pollution status in India, Central Pollution Control Board conducted a study in 2022. Every year they are monitoring the water, and the CPCB, Central Pollution Control Board, has 4,484 locations in the river systems, covering 28 states and 7 union territories. Out of the various rivers, they, based on their initial screening, they selected 603 rivers and were assessed for the water quality, particularly biological oxygen demand. Based on the study, they have found that 311 polluted stretches covering 279 rivers. That means 46% of the rivers are polluted in India. And Ganga is the most polluted river. We all know that. And based on the study, it has found that earlier in 2018, 351 polluted rivers. Now it has come down to 311 stretches. So they say that there is a major progress in the reduction of pollution sites in India. And I will show you a map of India. Then we will go to the nature-based solution. This is a map of India, and this dark colored portion showing the most polluted surface water systems. And Maharashtra is the most polluted region, followed by Madhya Pradesh, Uttar Pradesh, Bihar. And these white colored portions are relatively safe. We can see Andhra Pradesh, Haryana, Punjab, all these things relatively safe. But if you come to Karnataka, moderately polluted, Kerala, moderately polluted. So the dark shade increases, it actually showing the more pollution there. So I think we have participants from all part of India. And why this Maharashtra state highly polluted? Mostly due to the industrial pollution there. Okay, thanks to Andhra Pradesh and some of the other states here, no much pollution. They properly, I think, to some extent, they treat the water there. So what is the solution for the water pollution? Whenever there is a pollution water, don't clean the water there. You have to go to the catchment area of the river system, catchment area of the lake system, identify the source of pollution there, stop that pollution there, treat the water there, then release it to the water body. That is the solution. Unfortunately, our politicians, they have no idea. Whenever there is a polluted river or a lake system, all of a sudden they ask the people to come for the cleaning of the lake. On the other hand, from the second day onwards, again the same pollutants are coming. So instead of touching the water there, what they have to do, if they clean the water on a particular day, it's a waste of time, waste of money, waste of energy. They have to go to the upstream area, identify the source of pollution, stop it and clean it there by various ways. So Normally, we have the sewage treatment system like primary treatment, secondary treatment, and tertiary treatment system. All these things are there. Most of the factories and industries, they try to treat this water. Okay, sometimes they completely treat it because a huge amount of power is generated, needed, money is needed to treat this water. But some of the factories I know in some states, they are not fully treated. During midnight, they partially treated water will be releasing into the nearby water bodies. That is creating problem. This is the example of a sewage treatment plant. But we need a safety tanks, all these things at the domestic level, the proper 3-layer systems to avoid such contamination. So now I will come to the heart of this topic, that is constructive wetlands, a nature-based solution for water pollution. What you see is a garden. I would say it looks like a garden. You can see the colorful flowers are there. Below, behind that one, you can see some kind of plants, some kind of grass systems are there. Seems to be a Mughal garden or a Mysore garden, whatever you can say. But this is not a garden. This is actually a wastewater treatment location, wastewater treatment plant. Below this garden, wastewater is flowing. But when we see it look like a garden. There is no flies here, no smell is there, no mosquito is here. From the top, it seems to be like a garden. Like a garden, you can go there, you can enjoy the particular garden. It's aesthetic beauty, all these things. Okay, I will show you more slides, then you will get an idea. What do you mean by constructive wetland? So the earlier shown figure actually showing a constructive wetland. Constructed wetland is nothing but it's an engineered systems designed and constructed to treat any kind of water using nature-based solutions. That means using the wetland vegetation, soil, and the microbes that attach to the soils. So it can treat, theoretically speaking, it can treat surface water, groundwater, all water contaminants coming to the water bodies. So it can be considered as a decentralized wastewater treatment systems. When we say as decentralized, it means from the source itself, we can treat the water, wastewater. Wherever it's originating, that particular location itself, it can be treated. So it's a strong, robust technology, low-tech technology. Low-tech means technology is not very complicated, very simple, but at the same time, it's very strong and a low operational cost. It has only one-time payment. Once you establish this one, after that, no further payment is needed. No power supply is needed. Automatically, it will work. It can be considered as a secondary treatment techniques. I have already shown you sewage treatment plant, primary, secondary, and tertiary. So this type of can be considered as a secondary technique. It's an aerobic, that means oxygen is needed for this one. Before wastewater getting into this constructive wetland, some kind of pre-treatment is needed. That means the suspended and solid materials has to be separated. Okay, and very little sludge is generated as a part of this one. This can be, theoretically speaking, any type of wastewater can be treated, but mostly it is utilizing the domestic wastewater, and almost all countries in the world like Europe, USA, even Israel, they are using this type of technology for treating wastewater. It can be attached to the conventional sewage treatment plant also. In almost all climatic condition, dry climate, humid climate, like Indian climate, Kerala climate, super humid climate, in all these conditions, it can be operated. So when we look into the classification of constructive wetland, mainly it has two components. One is the surface, based on the flow condition. One is the free surface water flow, and the second one, subsurface flow condition. Free surface water flow means water is flowing on the surface. That means you can see the wastewater on the land. It's not good. It will create problems. It will create foul smell. Flies will be there. So normally in the different parts of the globe, they prefer subsurface flow condition. What I have shown you earlier, the garden, it is the pure subsurface flow condition. We can see the garden on the top, below which water is flowing. It never comes to the surface, and we use some aquatic plants and to treat the water. And so this is actually the classification of constructive wetland. We have the surface flow type of wetland. We have the subsurface flow types of wetland. Then below the subsurface, category, we have different types of categories are there. I'm not going to the details of all these things because I just tell you what is the concept of this one, whether it can be applied in various parts of India for treating the wastewater, domestic wastewater. And usually we use sand bed or gravel bed systems to treat the water. Again, I'm coming back to the same picture which I have shown you earlier. This is a garden, and I will show you the cross section of this particular garden, how it is manufacturing. You can see this different photographs here. Suppose if you take a plain land area for a constructed wetland, first of all, we make a large pit over there with 1 to 2 meter depth and a large area. You can see a small pit over here. This pit, the bottom portion of the pit is actually not horizontal. It is grading. That means there is a slope there at the bottom, and this that means it is divided into so many compartments. So this pit is actually filled with the gravel. You can see the dumping of gravel over here. At the bottom we have the plastic polythene sheet to prevent the contaminants from going to the groundwater. Then it is filled with the gravel. It can be sand or gravel. Nowadays sand is very costly, so use gravel to fill that one. At the top we have the coir pit or soil is there. Then this flowering plants, indigenous domestic flowering plants are actually growing here. We can use any type of lot of research going on. What are the suitable flowering plants we can use for this type of thing? What is the capacity of the plants? It varies from plant to plant, but here you can see different types of plant we can use. But this plant should have a fibrous root system, and it actually spread over large area so that more contaminants from this can be absorbed by the system. So this is actually the cross section of this particular sewage constructed wetland cross section. So the pit is shown here in this cross section. You can see the pit. It is filled with the gravel here. You can see the gravel here, and over the gravel, these are the plants growing. Different types of domestic plants you can use here. This is the root system of the plant system, root system. So in the wastewater, after filtering all these things, it is coming here through the inlet pipe here. It is slowly moving along this particular area because of the variation in the slope at the bottom. At the top, it is seems to be horizontal, but at the bottom, there is a variation in elevation. So there is a gravitational flow. It is slowly moving from one end towards the other end, few meters per day in that way. Because of the, now there are so many activities going on here. The plants are here. The root of the plants can absorb the nutrients. So filtration process will be there. Some of the activities like physical process, chemical process, biological process operate in this root zone area. A combination of this process ultimately gives rise to almost clean water. It is coming out from here. It is collected in some other place here. So this is the major treatment area. We call it as the root zone area, and where the treatment is going on. And these are the various locations in this where the treatment is going on. We can call the various process here. We call it as the physical process, chemical process, biological process. Physical means sedimentation is there, adsorption process there, filtration there. So this process actually remove the floating particles or the fine particles there. Then the chemical process mainly means precipitation. Those dissolved contaminants or nutrients will be precipitated and it will be separated there. Biological process mainly with the help of bacteria. Biofilm, the sand particles there, gravel is there. On the surface of the sand and gravel, a biofilm will be developed, and this biological activity, bacteria, it can do certain things like nitrification process, nitrification, all these things. Anyway, the nutrients will be taken up by the plant roots. So a combination of this physical, chemical, biological process and the plant's root absorption of the nutrients by the plant roots ultimately give rise to what we call it as this type of this is the technology you've shown here, close-up of the root system, where oxygen is coming from the atmosphere, from the air, and it is aerating here, and all the biological, physical, and things are there. As a result, nutrients getting reduced. BOD, I already mentioned about biological oxygen demand. or the organic matter is getting oxidized or broken down by the bioactivity of bacteria, BOD getting reduced, organics will be removed, nutrients will be removed, even pathogens will be removed to some extent. Ultimately, these are the process that takes place. I'm not going to the details of each process, how the organic matter is removed, how the suspended solids are removed. So various things like in nitrogen, phosphorus, pathogens, even heavy metals can be removed to some extent by this activity. Ultimately, our aim is, as per the Central Pollution Control Board, the pH of the water should be in the neutral condition, nearly neutral, and this suspended solid should be below 60. BOD should be low, COD should be low. After treating, the water cannot be used for drinking purpose, but it can be used for other activities like consumption purpose, gardening the plants, all these things for the purpose. So plants normally used for this one is Napier grass system, vetiver plant, Echinacea, etc. So this is a commonly used today. Even any type of plant we can use, which has some root system, fibrous root system, and which can absorb the nutrients. So this research, this type of constructive wetland started in Germany by a famous scientist, Dr. Seidel, in 1952 at the Max Planck Institute. This is one of the world famous research institute in Germany. After this 1990s, it got attention from various factories or industries to treat the wastewater. And almost all parts of the world now use subsurface flow of the things. And I will now show you one important company. I had an Indo-Israel project. I have been to Israel 2-3 times. So Israel is a arid country. Water is very low. About 85% of their water they get from desalinization plant. Remaining 15% of water they get from the treated water by the wastewater treatment. ILA is an agency. ILA is one of the leading agency in Israel treating the wastewater using this phytoremediation or constructive wetland. This is a photograph of a constructive wetland. If time permits, I will show you a small video as well. And ILA agency now in India, they have an office at Bangalore also, and they have started some projects in the treating of Ganga, Yamuna rivers as well. So I will show you one. So this is a small type of domestic wastewater treatment technique which I mentioned about constructive wetland. Earlier we have shown is a large area, garden-like one. If you have a large surface area, you can go for that type of treatment. On the other hand, if the area is very small, you can go for box-type constructive wetland. So this is one box, much length is that more than 10 feet length, hardly 2-3 feet height, and it is filled with sand, and it's filled with, then at the top you can see the plants there. Such boxes can be kept to one in a serial fashion, one after another, and different elevation. So wastewater is coming to the box number 1. From there, partially treated, it coming to the box number 2. From there, it is coming to box number 3, and finally it is coming out here. So it is almost treated. Domestic level also, small scale hotels also, you can use that one. So instead of directly releasing wastewater into the water bodies, this type of box-type constructive wetlands nowadays are available in different parts of the world. Even in Kerala also, one of the research organization has started this type of box-type constructive wetland. I will show you a case study which we conducted in Hyderabad. This is actually a golf club in Hyderabad. We call it as Golconda Golf Club, one of the famous golf club. I am here. Our team from Trivandrum CET, Engineering College, actually visited this particular place. Now, Golconda Golf Club was actually more than 100 acres of land, grassland. Every day they have to water this grassland. Golf club activities, golf, that game is going on there. So they had to spend lakhs of rupees every month for the water bill. So they started thinking of a solution, and they actually searched in the web, and they found that wastewater can be treated using this type of technology. Fortunately, near to their plant, near to their golf club, there is a drainage going on, public drainage, government wastewater drainage. They thought of treating that water and taking that water for this activity. So this is actually the Gold Club area, grass coat in the region. So these are the area they have to water every day, because otherwise it will be. So this is actually what they did was they collaborated with the ILA agency Israel. So this is actually a part of the wastewater going near to the area. They diverted to this particular box type. You can see you can see the wastewater coming from the drain outside. Entire wastewater they are not using, only a part is there, collecting into a first in a tank here, then it is going to a settling tank here. You can see the settling tank wastewater, and at the bottom you get the suspended sediments, all these things. At the top you get a calm and clean, almost clean water, and this clean water is collected from here. You can see the pipe over here collecting the almost clean water from the top. Then it is diverted to another tank here. From there it is going to the constructed wetland. You can see this is the panoramic view, long shot of the constructed wetland. He is this particular t-shirt wearing man. He is actually a mechanical engineer looking after this constructed wetland now. He is actually briefing all the activities going on here. So these are the various types of, this is a large area. You can see the gravel, all these things. Plants are growing here. Different types of plants I will show you. So construction of this constructed wetland. This is the center portion of this 100-acre land. You can see a lot of other activities are there. You can see the flowering plants. It's not started flowering. So this area, you can see flowered plants here. Different types of domestic plants they used for this area. And you can see the gravel over here. And you can see there are so many engineering designs there to allow the water to flow. Otherwise, it will come to the surface. So the interior design is actually a skilled work, and only the technocrats, they know how to. These are some of the things they constructed inside to allow the water pressure, to maintain the water pressure, and should not allow the water to come to the surface. So these are the photographs of this. And when we see this board, you will see that it's a treatment plant, environmentally sensitive area. Okay, here it is mentioned that sewage treatment plant is there. Otherwise, nobody will understand, because you can come here. There is a coffee shop here. You can take coffee, snacks, all these things, because it seems to be a beautiful area. No smell, no flies, nothing is there. Once you see the board, you understand that this is a treatment area below which below the flowering plant, the polluted water is going on there. So finally, after the treatment, the water is allowed it to fall in a pond. This is a pond there, and they allow the water for aeration, and you can see like a fountain, water is coming up, mixing with the air. So you get clean water here. You can see how the aeration is done. So this is the final treated water they collect in a pond. This water can be used for various activities like construction purpose. Every day, so many water tanks coming and taking the water. So they get money also. So this is a one-time payment. And see, this is the final water, and this is the first water. When we visited this plant, and this is a worker there, he collected this water from the settling tank that we see at the first site. Okay, you see the color of the water. Lot of turbidity is there. It's a dark color water, and this is the water he collected just in front of us from the pond. See the change in difference. You can do the physical, chemical, biological analysis of this water, and finally you can come to the conclusion that this water is a good water for, and it's not good for drinking purpose. They say that, but they get this lakhs of liters of water for their purpose. So constructed wetland is one of the useful technology which you can apply at the domestic level, which can apply various on the banks of the river systems for various industries, factories, even flat systems, multi-story buildings, and various levels can be applied. We don't have a large area. Depending upon the availability of the land area, we can use this type of thing. And in our department, we constructed a small thing for us on a experimental basis for our MSc students and PhD students project work. And this is a small thing we set up there. Wastewater is already here, it is going there, and you can see using some plants, it is treating there. And water is a very important natural resource, and it should be properly treated for the present generation as well as for the future generation. So these are some of the things I want to bring your kind attention. Now the take-home message is nature-based solutions are possible to treat the water. When the one-time payment is there, once you establish that thing, natural flow will be there. It will treat the water, and once the plant dies, we can replace with the new plants. Some kind of maintenance is needed. No much effort is needed after the construction. So it can be done at the rooftop of the buildings. It can be done even the small areas of the land on the banks of the river itself, upstream part of the river, on the in a factory area. Also small garden like this type of can be constructed. You can attach it to the sewage treatment plant itself as a secondary or tertiary treatment method. So different kinds of things are possible. So that's all about my presentation. Thank you one and all. If I welcome your questions, if any, from your side.
Thank you, sir. Thank you for that very thoughtful and wonderful presentation. It was indeed a pleasure to listen to you, and so many practical ideas have been generated through your talk. I'm sure our participants will have a large number of questions to ask to you. They may have some comments as well. However, I feel due to the positive time, we will limit it to the next 10 minutes or so. So, Director RSK, sir, shall we start with?
Yes. Thank you very much, sir, for such a nice presentation. And in fact, what we have seen is that in the state of Kerala, some nice experimentations have been done. But how we can replicate such things in other parts of the country? Actually, this is what I was wondering. Means these things don't seem to be economically also very viable. Means the community doesn't have to spend a lot of money also in implementing these things. But why is it that people don't accept in other parts of the country? I have rarely seen such things happening. So how can it be replicated in other parts of the country? This is something which comes to my mind immediately. Particularly, in our Unnat Bharat Abhiyan villages, particularly we feel concerns on this matter because they are the villages where our people go and our students actually go, and we actually try to understand their problems and give them meaningful solutions. I think if with these kind of things, we can make very meaningful contributions in those villages. That is something which is very important. So could you suggest some ways of replication of such things in villages? And what kind of means if in a particular village, if these things have to be tried out, how much of initial investment will be needed for them to do it?
Hello, sir.
Yes.
I'm Mr. Hassan. Can I ask a question, sir?
Pushpasan, sir?
Yeah.
Sir, complete his question.
Yeah, I shall list 3 questions, sir. One thing.
Sir, please wait. Let Sabu sir answer the first question. After that, you can ask your question.
Okay. I shall wait.
Sir, actually, this is a technology. It has initial investment a little bit high because we have to calculate the area, because square meter area, first of all, depending upon the particular availability of the area, we have to calculate it. Sometimes it will go even more than 1 crore in the case of constructible area. So depending upon the type of the effluents coming from the particular factory, we do some analysis of the effluent, what type of treatment. That the design is very important. That is from this.
We will
one time payment is
we will need your help also. We will organize few more programs in this, and we will seek your time.
Sir,
and
if you
for our, in different regional centers, people have adopted villages, and we actually these things are very important in those villages. And then if you can interact with our regional directors someday, and then They will make presentations about those villages and exact situations happening there. And then after that, if you could help us in making some exact meaningful interventions, that would be very nice.
Sir, if you give me 1 minute time, I will show you a small video, 1 minute video, which I took from Israel. You can see a small area, how it is treated, and how we know whether the water is treated. They allow ornamental fish to grow in the water. If fish can grow, it's a biological indicator. The water is almost clean. I will show just one video. After that, we will go to the question. One small video, 1 minute video. I have so many videos with me. I will just get a glimpse of this. Can you see this video?
Yes.
Yes, yes.
Yeah. What you see is actually the Tel Aviv, capital of Israel, part of the area. Hotels are there on the side. No, you can see the flowering plants. No, the grass type plants there, and the water. As you see, is the treated water. So it's actually the heart of the area, Tel Aviv, and the multi-story buildings there are there. It's a tourist area. People come there. There is no smell there. No, nothing. No flies are there. What you see, the water is treated water after the treating by this various grass plants there. And if you come further down, you can see the ornamental fishes actually in the water. So tourists come, they feed the fish also. If the fish can survive in the water, it's indicated that this is a clean water. This water is recycled for various activities there. So strong wind is blowing there. When I took the video, that's why you can see the some. I will show you the ornamental fish over there. Okay, now you can see the ornamental fishes in the water.
Yeah.
So it is there. It can live. It's an indication that the DO is there. Dissolved oxygen is there. DO is very low.
Yeah.
So people come, they are actually feeding the fish.
Okay.
So India can also have, if there is a vision and if there are experts there, in the heart of the area, in Kerala, in other parts of the metropolitan cities, the tourist spots. Instead of polluting water, we can convert it in this type of garden and we can treat water. Okay, thank you.
That's really great.
Sir, sir, can you hear me?
Yeah.
Please, yes, please.
Sir, it was during the talk you mentioned that Maharashtra is the most polluted area in water. But as per our common, Delhi is supposed to be the most polluted air pollution area. So my question is,
Correct.
does the air pollution has no effect on the water quality? That is my question number one. Question number two is, you have told throughout the talk that the final output can be used for construction purpose or other purpose only, not for drinking purpose. So, is there any method available by which we can treat the polluted water and bring out the quality of water such that it is safe for drinking or other taking purposes? Then third question, at the beginning we have mentioned that in the moon, it may take some 3 days to come take water from there and bring water from Kerala, India. But 2 months back, NASA has told that they have discovered some caves in moon where fresh water is available, and then they can convert that water available caves there. There is some underground caves present on the other side of the moon. So in that case, if that technology developed, will it be needed to take all water from here to there?
Thank you, sir. Thank you for the question.
Thank you, sir. Thank you very much. Actually, very interesting question. As far as air pollution is concerned, Delhi is the most polluted. Delhi and its suburbs are the most polluted cities in the world. We are coming in the first 5 rank. If you take the 20 cities, it's mainly from the particulate matter in the air. We call it as PM particles. PM 2.5.
PPM, yeah.
Okay. So that is there. Then pollution, mainly other oxides of mainly the gaseous and particulate matter is actually creating problem in Delhi. It's due to the burning of the agriculture residue from the
hair burning, etc. Haryana hair burning. Okay, that was the reason.
Okay, but the river pollution mainly from the solid waste and the liquid waste. That's the issue.
Oh, that may be.
That may be the reason. If there is no proper solid waste treatment there, it can lead to. India, we have the particularly people from Kerala, we have the conventional of throwaway culture. Even hotels, the house, all these things, they throw into 2 places. One is the riverside and the other one roadside. People think that these are the no man's land. Taken for granted.
Yeah.
You got it, sir.
But but the atmospheric pollution is so high that atmospheric air will get coming into contact with the river surface. Will that have not an acidic effect and make the water polluted more? Or?
Okay, polluted, sir. I agree. But more pollution is from the soil and from the solid and liquid water, liquid waste, domestic waste water from the city area, all these things. We need to have some drainage, sewage drain system. Properly. Otherwise, if you take in Kerala, the Trivandrum, we have the Karamana river system. On the banks, there are 8,000 houses without proper drains. So they put a pipe into the water. 8,000 houses. If they
that is visible. When you photograph, it is visible. The density and colloidal matter, that difference is so high that is why the 2 different layers are there. Otherwise, the water might have merged together. A layer won't follow that. The layer is created only because they are so much variable in densities. Ramana River and that river, the merging point.
Your third question regarding the water in moon, actually, I normally say that NASA, when they become shortage of fund, they will come out with some photographs showing evidence of life, evidence of water, all these things, and they get some
not NASA as well as Chinese probes. Both of them discovered these hidden caves, but on the other side, and they are now saying that when we develop this technology, we will be rich in water there. I don't know. I have only read from the newspapers. Then one simple doubt, sir. The rainwater coming from atmosphere after 1 or 2 or 4, maximum 5 rains, then the water will be fresh. The atmosphere will be clean. So can we organize some method for which a person can collect the rainwater for his own, her own purpose at his home? If we develop a technology like that, at least a little bit of water for drinking water can be gathered like that.
Yes, sir. It's possible.
But why I am asking this is because some 20 years back in our area there was complete disruption of power supply, and what we did was at that time in Trivandrum there was heavy rain for 1 week. So after 2 or 3 days we started collecting the rainwater in buckets and boiled it and used it for our cooking purpose, etc. That is why I am asking if we develop some technology. Now we are asking people to do rooftop cultivation, rooftop growing of vegetables, etc. So, and rooftop electricity, that thing. So, why can't we ask the government to develop a strategy so that people can collect water from rain? When there is adequate rain and open to their terrace, etc. Can it be make the viable alternative for at least for some a few liters of water per day?
So we started this project. It's a very important thing because community level, we have this level 3 activity in our university. Almost all things after the research, we have a community development program in which we construct rainwater rooftop rainwater collecting and storing tanks. We call it as ferro cement tank. And once the tank is full, it is overflow is going to the dug wells. So as I mentioned earlier, we have the water quality issue also. So day-to-day activities, the community get the water from the tank. Then during monsoon season, we are recharging the groundwater. That's important. We need to have a vision, long-term vision, recharging groundwater. So unfortunately, India, China, we are taking out too much water, but not giving. We should have a give and take policy. Not taking, but giving. That also we need it.
We should also give water back to we should also give water back to earth.
Yeah, thank you, Person, sir. Thank you for your question.
Thank you for giving me the opportunity.
On the chat, our colleague, your colleague, Dr. Moni Sahai Didi, she is asking a question. Constructed wetland is a very good and replicable idea. My question is that we have natural wetlands which maintain the ecological balance of any area. However, they are diminishing in number either because they dry up or are encroached upon. Can the same technology be used to maintain the existing natural wetlands or other technology in case they are drying up? I think that is relevant for our Kuttanad area also.
Kuttanad area. Oh, sorry, you are from Kerala?
I am from Kerala, but
Sir, the problem is
not from Kerala.
In the case of natural wetlands, because when we wetlands are polluted, pollutants, the wetland water has to be pumped into some other place to treat it, because these natural wetlands are connected with the groundwater also. So these are the recharging sites of the groundwater. So the drains that is coming to the natural wetlands may contain these pollutants. So go to the upstream area of the natural wetland, and wherever the pollutants are coming, identify source of pollution, there itself we can have small type of either box type constructed wetland or type, as I mentioned earlier, depending upon that is needed. Actually, we have the photographs of the Ganga river on the river beds itself, where there are so many tributaries, small streams coming. On the banks of the river, there are small factories or industries. There they put this one. So it is like a network system. Go to the upstream area, treat the water in the place, then slowly it is coming. Ultimately, the natural wetland that we call it as Kuttanad region or the Vemanad region or the Ashtamudi lakes in Kerala, we receive almost clean water. So don't treat the water in the water body itself. It's not a solution. It's only a foolish idea. The source of the pollution should be identified and it should be mapped, and then go for various treatment techniques. That is the thing we have to do. Unfortunately, our ministers, our politicians, our top leaders, they have no vision regarding that one. They simply go to the river system, treat it, but the next day, the same thing is coming again and again, creating problem. Thank you.
Sir, thank you so much. Can this system be actually be part of our housing mechanism?
Yes, sir. It is possible. It is possible. In Trivandrum, we have a ISTU organization. They have developed a box type thing, maybe 1 lakh rupees. I told them to go for some lower price, maybe 10,000, 15,000 rupees. So it's a system which can be connected to the safety, even our domestic, for example, our wash basins or all these things. Instead of directly releasing the wastewater at the domestic level, it can be connected to the box type system. From the box type, it can be go to a pit so that it recharge in the groundwater, or it can go to the drains. So that type of system can be adopted wherever more pollution is there.
That's a very good idea, sir.
I have seen that particular thing developed by our colleagues there.
Sir, Director asked me, sir, if the price can be lowered then, by some technique, then we can actually have this technology implemented in many of our UBS sites also.
Yes, definitely we can. I think that is what I was wondering, means in what way we can try out these things in the UBA villages. That will be very useful, because in Kerala such nice things are happening, but in other parts of the country rarely we see such things happening. So why is it that these things are not getting replicated in other parts of the country? One thing which comes to my mind, sir, that is means after treatment, this natural treatment, you said that it can be utilized for agricultural purposes. But can the other bacteria and viruses which might be present in those water bodies, once we utilize it for agriculture purpose, again they might get circulated in the food chains. So means for the construction purpose, fine, that can be done. But for agriculture purposes, because then it gets immediate contact with the food chain.
We can test the water. Every week, or we can test the water and the quality can be assured. Then only we can give for agriculture. In the case of gold crop, they need only the grass. Grass is there. That is only for the that activity. No food chain. It is not going to the food chain. It is not up to the. That's why. But it's possible, sir. I have seen how Israel is doing all these things.
Yeah.
They know the price of the water. Even single drop of water, how they conserve it and preserve it, and how they are actually making wonders, particularly fruit production. Maximum fruit production in the world coming from their country.
The micro irrigation program there is very successful.
Yeah, even if there is more than 20 centimeter thickness of soil, they go for cultivation, drip irrigation. You can see drip irrigation, one of the beautiful thing. Timer based drip irrigation. Everything is automated. In India, what we do when we plant a tree, every day morning we have to go for and watering that's a tedious job. For me, it's not possible. I will not be available. What they do, Israel, they actually from the tank itself, from the water tank, it is coming to the plant. There will be small pipe there at the bottom of each plant.
Yes,
so drip irrigation,
yes.
timer-based drip irrigation, automated one. If you have an Android phone, you can program it wherever you are in the world. You can see whether morning and evening watering possible. 10 minutes, 50 minutes, you can set. If water is there in the tank, it will come there.
Yes,
So
you had mentioned in your slide that means maximum water is being utilized for agriculture purpose.
Yeah. India, what we are using.
Very strange, Means,
Sorry, India is a water-stressed country.
yeah.
You know that one. Nobody clearly know. We thought that so huge rain is there. After 2050, we will suffer. Water table has gone down. If you look into the water map of the world, water system map, India, China region, Southeast Asia, most of the activities going on. Food grain production. Our diet pattern also changed. Now we are eating more meat. To generate 1 kilogram meat, huge amount of water is needed. That's a problem.
So I think that we can take one more question, which has been asked by our regional center at Devgarh. The question is, receding water table is challenging in urban areas, affecting availability of safe drinking water. In a state like Jharkhand, due to the reckless urbanization, there is pressure on wetlands. In this situation, what micro level initiative are needed in your opinion, specifically in cities? Administratively, urban bodies, municipality, etc., try to make water harvesting compulsory in maps. However, it used to be eyewash in many times.
Sir, it's a very good question. Actually, in China, they use the term sponge city concept. Sponge city concept. Sponge is a solid material. It has so many spaces. If you put the sponge in water, the air will be replaced by water. When you take out the sponge, if you squeeze the sponge, you can see water coming out. Similarly, in urbanized areas, the small ponds, if you conserve and preserve, they will be acting as water holding areas. Each pond will act like a sponge. Whenever flood comes, the water will be stored there. Flood water can be accumulated there. During drought season, the water from the pond is going to the groundwater. So the sponge city concept, like used in China, we can have, unfortunately, in the metropolitan cities like Bangalore, all these things, they filled the wetland. Even Chennai, they've converted wetland into multi-story buildings. That's why flood affected last 2022 in Bangalore, 2000 to 2015 in Chennai. So we need to conserve the wetlands. It can be converted into a park, amazing park within the city. That's a very interesting thing. And the walking space can be provided. So some machinery should be there, so that this area can be considered as a water recharging area as well. So rainwater harvesting and the conservation of this type of will be useful, and otherwise it will not be possible. Jharkhand, I don't know. I have not seen Jharkhand so far, but based on my knowledge, I am sharing my humble thoughts.
Thank you, sir.
More discussions later.
Thank you, sir. It has been a very exhaustive session. I'm sure there are many more queries, but due to the paucity of time, we have to draw this discussion to a close. So, Director RSC, sir, shall we go to the final proceedings of this session, sir? Okay. Now, I request our Assistant Registrar. Sir, shall we draw this to a close, sir?
Sir, please.
Okay, ma'am.
Sorry, sir. Sorry for delay.
No problem.
Actually, Sadhu sir, it is a second opportunity for me to have an experience with you, sir, because earlier an experience in the HRD, Kerala University, for this refresher program.
Okay,
really,
thank you.
I was very eager to hear your voice again, because I know your resource and your presentation style and all. Today also it was very wonderful and informative. A lot of new things we got. And I and Rajesh sir, together we have one MOOC course, sir. A lot of information regarding this water conservation, protection of earth and everything. We have recycling of water purification, etc. We have included in that MOOC. And actually we were assuring our resource and our content materials genuinity by hearing your class, sir. I have one doubt that, sir, nowadays in Kerala especially, one particular type of cultivation process is going on. Even in CL, under the solar panel system, they are cultivating, and we are using a coverage of plastic over the surface of the land to protect surface soil and for avoiding the weeds, I think. And you were also telling that when we are preparing this wetland cultivation, at the bottom part of the wetland, we are using polythene covers. Definitely, I think that in later stages it will be again contaminating with the microplastics, no? Do we have that?
Yeah. But here they use very thick plastic, thick polythene bags, thick polythene sheets are there you using. It won't decay. It will preserve for a long period of time. Because plastic has a long life cycle, 500 years ago. Normally we say that. When we say about one bottle of water, we say that for the production of bottle 5 seconds, drinking water 5 minutes, and once you throw into the environment, it will for 500 years. 5 seconds, 5 minutes, 500 years. That's the life cycle of a water bottle. That is one time using. So it will have a long life period. Once we stop this particular activity, you can remove the top material and you can retrieve that one. We are not throwing it to the environment. What you said is correct. You have to be very cautious regarding plastic pollution aspects. But when we use thick plastic, it won't decay. It will take a long time. That's why. Because otherwise we have to go for some kind of concreting. It's very costly. But because we have to prevent the pollutants from getting into the groundwater. That is the most important thing.
But I don't think that most of the people who are, the laymen, they are using this plastic in their cultivation process. They are not removing it, and sometimes it is decaying. And it becomes dangerous. I have seen it several places. So some measures should be there from the part of the local self-government or something to monitor it and do that. Because in Kerala, Harida Karma Sena is doing a lot of things in this regard as the part of Kudumbashree, no?
Yeah.
So if you, from the department, if you are insisting this matter to the panchayat level people, definitely some instructions and this awareness programs will be there among the communities. I think, because it is happening there in one Thuruthikara Panchayat, it is in Mulanthurthi, Ernakulam district. It is a green panchayat. And it is in the UNESCO map as noted as a green panchayat. Pacha Thuruthikara it is called. I am also from Kerala, but now I am from Mizoram. It is what I am telling. So that type of initiatives should be taken from the part of Udat Bharat Abhiyan or something. I think IGNOU can, especially wherever this special kind of cultivation is going. Thank you, sir. Thank you very much for your.
Thank you for your valuable contribution. We will think about that very seriously. Okay.
Okay, sir. Thank you. Thank you very much.
Thank you, sir. Thank you for the response and thank you for the question. If anyone else wants to ask one question quickly, you can do that, or else we will go to the final stage. Okay, sir. Shall we draw it to a close, sir?
Yes, yes, we can have. Thank you.
So, sir, now I would like to request our Assistant Registrar, Sri R. Raja, to deliver the formal vote of thanks.
Thank you, sir. Thank you. Honorable Vice Chancellor Madam and respected Dr. Umesh Chandra Pandeyji, Director, All India IGNOU Regional Service Division. Thanks for your welcome address, beautiful address. And also, thank you for confirming it from the SAR, the estimation of the project to establish in Unnat Bharat Abhiyan, because RSD Director is the godfather for all the region and all over India to grant their funds. So I'm very much thankful for your concern as well as the welcome address. Thank you, sir. For today's quote, save water, secure a suitable planet. And thanks for respected Senior Regional Director, Dr. M. Rajesh Trivandrum, and coordinator of today's wonderful event. Thank you for your wonderful coordinatorship and clearing some doubts related to the environmental issue. It is beautiful. Thank you, sir. And today's quote, water is a life, water is a gift. Thank you. And thanks to Dr. T.R. Satyakirti, Assistant Regional Director, beautiful explained about the speaker, a beautiful, wonderful introduction about the speaker. And for you, the today's quote is, the more water you have waste, the lesser life on earth. Thank you. Thank you for it. And at last, thanks for the audience who are encountered questions for which Pushpa sir, etc. And thanks for Madam Jalaja Kumari has given a beautiful, wonderful remarkable word about this presentation today. And final thanks to Professor Dr. Shabu Joseph, Professor and Head of the Department Environmental Science, Dean, Faculty of Applied Science, University of Kerala. It is not only this many designation. I can say towards this program, sir is a scientist. You are the scientist. One thing I can remember, during 1990, Dr. S.D. Makijani from Central Pollution Control Board, he has raised this issue. The Honorable Supreme Court has given a beautiful suggestion to establish the ETP in almost all sets. Because of that project only, now the slaughterhouse and this hazardous chemicals are been stopped, and the slaughterhouse and even almost all areas just covered. So we are very beautifully covered about all the areas, and even people are afraid to have any type of fish also nowadays, because Sir has covered very beautifully, and it is afraid to take fish, even milk also. Sir has explained about the milk. So I request, sir, you are beautiful briefed about the wonderful event today. And I would like to give a lot of thanks from on behalf of Indira Gandhi National University. And thanks to one and all who witnessed this program, entire country. Thanks for one and all, entire country. Thank you. Thank you so much. With Pranam.
Thank you for giving me this wonderful opportunity. Particularly Ajidharan Pillai sir, he actually involved me. That